All right, welcome to The Explainer. You know, circles are pretty much everywhere you look, from the pizza you're gonna have for dinner to the wheels on your bike. Today, we're gonna crack their code. We'll figure out exactly how to measure and, really understand these perfect shapes.
So to get us started, let's kick things off with a little puzzle. Now this might look kind of tricky at first, but just stick with me. I promise, by the end of this explainer, you're gonna have all the tools you need to solve this, no problem. Here's the plan. First, we'll break down the basic parts of a circle. Then, we'll unlock the formulas that make all the calculations possible. And finally, we'll put all that knowledge together to solve that bike problem and a few others. Sound good? Okay, let's dive in.
Okay, so before we can start crunching any numbers, we've got to speak the same language, right? We need to know what we're even talking about. So first up, let's get familiar with the essential parts that make up every single circle.
Think of it like this. Every circle has a heart, right? A center point. The radius, well, that's just the distance from that heart straight out to any point on the edge. It's really the most basic, the most fundamental measurement of any circle.
Now, what if you take that radius and just stretch it straight through the center all the way to the other side? Boom, you've got the diameter. It's the full width of the circle. And this means the diameter is always exactly twice as long as the radius. That's a super simple but absolutely crucial relationship you've got to remember.
And what about the outside edge? Well, if you were to walk all the way around the very edge of a circle, that total distance you'd cover, that's the circumference. It's basically just the circle's fancy word for perimeter. All right, so here's a handy little table with all those key terms in one spot. We've covered the big three: radius, diameter, and circumference. But check out those last two. An arc is just, a piece of the circumference. And a sector, that's a full wedge of the circle. Just think of it like a perfect slice of pizza. Easy, right?
Okay, so how do all these parts connect with each other, mathematically? Well, there's a secret ingredient, a really special, almost magical number, and that number is pi.
So pi, we write with the Greek letter pi, is what we call a constant. And here's what's so mind-blowing about it. If you take any circle in the entire universe, I'm talking a tiny coin, a massive planet, doesn't matter, and you divide its circumference by its diameter, you always get this exact same number. It's wild. For our calculations, we're just going to use the common approximation, 3.14.
And once you have pi, you can unlock these super powerful formulas. Check it out. There are actually two ways to find the circumference. One from when you know the diameter, and another from when you know the radius. And for the area, that's all the space inside the circle, the formula is just pi times the radius squared. This table right here, this is basically our complete toolkit for anything to do with circles. Okay, we've got our formulas. Let's put them to work, shall we? We'll start with the distance around the outside, the circumference.
All right, time for our first little test. The question is, find the circumference of a circle with a radius of 7 centimeters. So if you think back to that toolkit we just looked at, which formula is the perfect fit for this job? Yep, you got it. We're going to use the one with the radius. C equals 2 times pi times r. From here, we just plug in the numbers we know. So that's 2 times 3.14 times our radius, which is 7. You run the calculation and you get a circumference of 43.96 centimeters. See? It's that straightforward.
Okay, let's try flipping this on its head. This time, we know the circumference of this pond is 31.4 meters, but we need to figure out its radius. So, how do we work backwards from the answer?
Well, the trick here is that you don't even need a new formula. You just rearrange the one we already know. So if c equals 2 pi r, a little bit of simple algebra tells us that r must be c divided by 2 pi, right? So we just plug in our numbers. 31.4 divided by 2 times 3.14. And that gives us a radius of exactly 5 meters. Pretty cool.
So we've totally mastered the distance around the circle. Now let's move inside it and figure out how to calculate all the space it takes up. Yep, it's time to talk about area.
All right, let's find the area of this circle. But hey, pay close attention to this one. The question gives us the diameter, 10 centimeters. But think about our area formula, A equals pi r squared. What does that r stand for? Yeah, it's the radius. The formula needs the radius, not the diameter.
This is a classic two-step problem, a real common trip-up. So job number 1 is to find the radius. Since the diameter is 10, we just cut it in half, which gives us a radius of 5 centimeters. Now we're ready to use the area formula. We take our radius, 5, we square it to get 25, and then we multiply that by 3.14. The result?
an area of 78.5 square centimeters. So the big takeaway here is always make sure you have the radius before you even think about calculating the area.
Okay, we've done it. We've covered the parts of a circle, we've got the formulas for circumference times area. Our toolkit is officially complete. You know what that means? It's time to go back and finally solve that bike wheel puzzle from the very beginning.
Here it is again. The diameter is 60 centimeters, and the wheel turns 150 times. The question is, how far does it actually travel? Let's break this down into logical steps, using everything we've just learned.
Okay, here's how we crack this thing. One full turn of that wheel, well, it covers a distance that's exactly equal to its circumference. So, step 1, find the circumference. We'll use c equals pi times d, and that gives us 188.4 centimeters. Easy enough. Step 2, we just multiply that distance by the 150 turns the wheel makes. That gives us a big number, 28,260 centimeters. To make that a little more, useful, we can convert it to meters, 282.6 meters. And just like that, problem solved.
All right, let's tackle one more puzzle, and this one's a little bit tastier. We've got a pizza with a 12-centimeter radius, and it's cut into 8 equal slices. The question is, what's the area of just one of those slices? And if you remember from the beginning, that official math term for a slice of pizza is a sector. This one's a 3-stepper. First, we need to think about what fraction of the whole pizza one slice actually is. A full circle is 360 degrees, right? So, if we divide that by 8 slices, each slice has an angle of 45 degrees. Okay, step 2. Let's find the area of the entire pizza. We'll use our a equals pi r squared formula, which comes out to 452.16 square centimeters. And for the final step, we just need the area of our little 45-degree slice. Well, that's just 45 out of 360 degrees of the whole pizza, which is exactly 1/8 of the total area. So 1/8 of 452.16, that gives us our final answer, 56.52 square centimeters. And here it is, a final summary of everything we've covered today, all laid out in one convenient table. This is your essential cheat sheet for circles. It's got the diameter-radius relationship, the formulas for circumference and area, and even how to find the area of a sector. Everything you need. So now that you're basically a circle expert, here's one last challenge to really test your skills. To solve this, you're going to have to combine what you know about circles with what you know about the area of a square. So think about it. What's the area of the square? What's the area of the circle inside it? And how could you figure out what's left over? Give it a shot. Thanks so much for watching.